Okay, so I want to do 9a and 9d from the example packet. So let's take a look at 9a first here. So the first thing I want to do is write it in a form that we've been using. So 3 tan, and then we'll factor out that 2 and get x minus pi over 3. Now tangent, if we think about the original graph for tangent, I'm just going to sketch a very simple version of it over here. So tangent has asymptotes at pi over 2 and at negative pi over 2. And then it does this sort of thing. And then it just repeats that over and over and over again. And 3 important points on it are 0, 0, when theta is pi over 4, x is pi over 4, then tangent of that is 1. So the slope is 1 on that unit circle. And negative pi over 4, negative 1. So these are our 3 most important points, and then those would be the ones that would get shifted around and everything. So when I'm trying to graph 3 tan 2 parentheses x minus pi over 3, let's work our way through it. Vertical stretch is going to be 3. The b is 2, so that means my period is going to be, now normally we do 2 pi over b, but in this case the normal period of tan is just pi. So really it's always the normal period of your parent function over the b. So in this case it's really just pi over b, so it's pi over 2. Let's see, what else do we need? The horizontal shift is going to be pi over 3 to the right. Okay. So let's take a look at what this means. So instead of going, instead of this being a 1 and a negative 1, what we're really going to end up with is a 3 here and a negative 3 down there. So let me just write over this. So that'll be a 3 and a negative 3 right now. There's no shifting up or down, so that y value is going to stay the same. My period is only pi over 2, though, not a whole pi. So that means I'm going to have to shrink everything in by a half. So really it's like going from negative pi over 4 to pi over 4 now. And that's actually going to move these guys too, these little ones down here. This pi over 4 got shrunk too. So now that's actually going to be a pi over 8 because it got squished in by a factor of a half. Okay, so let's see, what else do we need? The 0, 0 still hasn't moved. Now we got to shift it pi over 3 units to the right. So everything has to get shifted pi over 3 to the right, which isn't super convenient because we don't have any over 3s here. They're over 4s and 8s. So if I go negative pi over 4 and I shift it 3 units to the right, then that's the same thing as saying negative 3 pi over 12 plus 4 pi over 12. So this is going to be pi over 12. So I'm going to get an asymptote at pi over 12. This one is going to end up, if I do pi over 4 plus pi over 3, you're going to end up with, let's see, 3 pi over 12 plus 4 pi over 12 will be 7 pi over 12. So really, this asymptote is now at pi over 12. This asymptote is going to be at 7 pi over 12. The pi over 8s are going to have to get shifted by pi over 3. Right? So let's do negative pi over 8 first. So that's like 3 pi over 24, negative 3 pi over 24, plus 8 pi over 24. So we're going to end up at 5 pi over 24. So that's this one. And then the pi over 8 is going to end up at, let's see here, so that's going to be 3 pi over 24 plus 8 pi over 24, so we're going to get 11 pi over 24 for that one. So this point will be 11 pi over 24. And then we've got enough to graph the whole thing. Oh, and 0 ends up at pi over 3, comma 0 still. So now we can graph the thing. It's still centered across the x-axis, but my asymptotes have shifted a bit, and it's squished it down a little too. So this is going to be x equals pi over 12. This is going to be x equals 7 pi over 12. And then I've got my curve coming right through here like this, and then my 3 points that I could label on here would be like pi over 3 comma 0, 11 pi over 24 comma 3, and 5 pi over 24 comma negative 3. So there would be 3 good points. Just making sure that works. Yep, that's all good. All right. Okay, I'll do D in a different video just so this one doesn't seem too long.